Hello, welcome to a new edition of Data in the Hallway. I'm joined by Matthew Penaroza. Hi, Matthew. How are you? You're like, go ahead. Sorry. Yeah.
Yeah, I'm doing good. I'm doing good. Yeah.
So yeah, and I think this is your like a second episode, I believe. So glad to see that we haven't scared you off in terms of coming back to our podcast. It's good to have you back. And Matthew, I mean, you're a sales engineer. You talk to a lot of our customers, so I appreciate that you folks bring a lot of real world experience talking to users and customers. So it's good to have you. And
Yep, I'm good to be
yeah,
on. Good to be on.
yeah, yeah,
Last time I think we had a lot of fun. I remember you asked me about something cool about Austin, and I was like, oh
yeah,
yeah.
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 So yeah, and then you came up with something nobody else brought, suggested. So that was awesome. So
Yeah, the tough one.
yeah. Yeah, and then yeah, today we'll talk about this is a pretty popular topic. I mean, you hope, especially for like young developers or companies that are starting out. As you're starting out in your career or your businesses, you're developing an application or infrastructure. You soon realize like you need to have a database
Hmm.
or a data store. And people obviously sort of, a lot of young developers or a lot of developers in general look at open source alternatives. And there are a lot of open source databases out there, which is a good thing. TiDB being one of them. And then want to sort of talk about, maybe different options that are out there and how people should sort of what kind of consideration, what kind of factor they should consider in choosing the right database for their solution. So I thought you'd be the perfect person for that. So it's looking forward to that conversation.
Yeah, no,
Yeah,
and I think that's it's like it's a tricky discussion, right? Because
yeah,
you're a new company and
yeah,
you're trying to choose a database, and once you choose a database, getting moving to another one is quite difficult. So it's actually like a
right,
pretty core decision that you make when you're building a new application, right? And so,
right,
if you're immediately starting off with like the wrong tool, it's gonna it might not bite you right away because I would say most databases, particularly from on the transactional side of things, like at a
mm,
small scale, can almost be used like in indistinguishably in with like the same use cases with like little issue, you know? It's
mm,
really when you get to scale that those issues really start to manifest, right?
right,
And I think that's you see that with like both like even your standard relational databases like MySQL and Postgres, right? Where you
mm,
hop on to MySQL, you hop on to Postgres, and things are going great. You're running. You get an extension. You have to do vector search. You get an extension with Postgres.
mm,
Runs that no problem, and then you start growing, and maybe you go from 1,000 QPS to 1 million, and you're
mm,
like, what do I do? And there's complexity there. And there's a lot of different like paths that you can go down, right? Is that you can
right,
theoretically take more complexity at the start to prepare for the future and also potentially
mm,
more cost at the start, or you can kind of just, play it by ear. But I think it's really important, particularly for newer companies, to have a plan. Like, hey, I'm going to
mm,
start on, and these plans can kind of like evolve with the time. Like, right, there's like maybe a new database comes out that handles this, but
mm,
it's like I'm going to start on MySQL and then go to TiDB, right, or something like that, or start with
mm,
Postgres, or go to one of the other distributed databases like Cockroach.
mm.
But yeah, yeah, yeah.
Yeah. No, I mean, I think you're right. I think the challenge that people are
Mm.
often trying to balance. I mean, you want to get your business off the ground, so you want to build something quickly, but then you have to think about long term as well. Hopefully, as your business grows, as your scale grows and your reach grows, then if you make a decision that you're going to regret 2 years down the road, it's not like replacing an app on your phone. Like the replacing it. I mean, I think somebody said the perfect analogy is like replacing an operating system. Like
Yeah.
it's not a trivial task. So although a lot of people, including both of us, I assume, want to get something off the ground, but you still need to think about a few years down the road as well to consider like what your path might look like. So,
Yeah.
and I mean, you like alluded to this earlier with MySQL and Postgres. There's a type of database called relational, and there are a few others, right? I mean, going way back to the basics, what are different types of databases out there that people need to think about? Uh, I mean, this is sort of a one-on-one type of topic, but I think it's important to sort of revisit some of the basic concepts.
Yeah, yeah. So I
Mm-hmm.
mean, well, there's a bunch of different ways to categorize databases, but
Mm-hmm.
I think the primary categories that I think about the market in, it would be, your standard relational SQL databases, your NoSQL databases, and then your new SQL databases, right? And so your relational, those would be like your Postgres, your MySQL, and then
Mm-hmm.
your NoSQL, that would be like your kind of Cassandra or your ClickHouse.
Mm-hmm.
And then new SQL would be, in that like the TiDB category, right? Or the
Mm-hmm.
Spanner. Spanner's not technically open source, but
Right.
in that category of databases. Yeah. Yeah.
Right. So, what are some of the I appreciate you providing those examples too, like not just TiDB, but Postgres and others in each of those three major buckets. Like what are some of the use cases that are appropriate for those? Let's go look at those three buckets, like relational, NoSQL, and NewSQL. Like what are some of the key use cases that are appropriate for each of those categories, would you say?
Well, I think with your your SQL, your relational databases, really the how this isn't necessarily how the market views them and how we
Hmm.
use them in practice, and there's kind of legacy reasons why that's true. But we really should be observant, looking at those databases like a starting point
Hmm.
from a relational perspective, unless you have very specific use cases or use cases that require well, one thing your single node relational databases are very good at is being very fast, right? Because there's no network traffic,
Hmm.
and when you're dealing with ACID transactions, the more hops that has to make among in like let's say a distributed system, the slower that transaction is going to be, and that's just a speed of light thing. There's no real architecture that can solve for that issue. So if you have really high and when I say really high latency requirements or low latency requirements, excuse
Hmm.
me, I'm talking like, sub millisecond, right? If you have that,
Right.
that's what I think when you really want to be sticking to those like single node systems. But another, I think going like even continuing on to the SQL relational database section, another really great use case for those, and I think is when you're starting out, when you're smaller scale, or you know that you're not going to grow to a massive relational data footprint, those are great because they're really easy to manage. They're really easy to set up. HA, that they're not super expensive, and if you're in a position where you're trying to grow your application, you have a million different other problems, then I think those are fine, right? Because when
Hmm.
you move into your distributed systems, even like in the NoSQL category, like Cassandra or TiDB, in the new SQL categories, as much as they make your life way easier in scaling out your relational database, there's still headache there. There's still like you need to have some sort of way of managing all those different nodes and coordinating with them, with like Kubernetes um, and whatnot. Um, but yes, as far and then on the NoSQL side of things, I mean, that I think, well, NoSQL is a kind of a broad category, right? So if you
Hmm.
have a need for, let's say, online analytics, you need real-time analytics, NoSQL is going to be really good at that, right? Because you can store data in a columnar storage format, so that when the database is actually doing like something like an aggregation, it can look for data, without having to scan the full extent of every single row. And so that would be a really excellent use case. And this is a common requirement in things like dashboards or analytical databases, or if you have a JSON workload, like you can use something like Cassandra, and they're going to have specific JSON functionality that's going to be much more suitable than a relational database. And then
Hmm.
in the NewSQL category of things, um, NewSQL's real use, and I think I think it would be great if it was suitable for everything. I mean, obviously I work for
Mhm.
TiDB, so I'm mildly biased
Right,
here, but its real use case is for those larger throughput, larger data volume workloads. And in my opinion, it's really not suitable, for those smaller scales. Not sorry, not suitable is the wrong word, actually. It's almost like bringing like a flamethrower to a fist fight.
hmm
If you were to use TiDB for like your WordPress website, I mean, it would
right,
do it fine, right? But it's like
hmm
it's kind of like overkill. And so those new SQL databases really are for those large, large scale workloads. But and those large scale relational workloads. So it's essentially you kind of think about it like a bigger and badder version of both MySQL and Postgres. Yeah.
right, right. Yeah, and then I think like when I sort of started this conversation, I may have been like a too simplistic. I mean, first of all, I don't think most people are just dealing with like one use cases, right? So they
Right.
may have like a multiple use cases, like a lot of customers that you talk to, and then they may be dealing with different types of data. It's like they might be dealing with streaming data, for example, and different needs. Like you might have analytical needs, and so I don't think use cases are that simple unless you're doing like a very simple application. But I think these like categorization still is still helpful. So
No, no, yeah,
yeah, yeah,
I completely agree. It's like, I
yeah.
mean, when it comes down to application logic, the things can get
hmm
so specific. And I've seen this in my own work where like,
hmm
people are choosing databases based upon some micro functionality. Just it's
hmm
one individual micro feature. And it could even come down to like how they do TTL. Like, does TTL, does it get rid of that data instantly? Does it hide that data? Does it remove it in a background job? It's like little
hmm
features like that. I often see customers, like really be hyper focused, right? And
Right, right.
almost the rest of the database is almost secondary to these individual nuances that suit their application. Yeah.
Right, right. Yeah, cool. Yeah, and I think like I think for like I mean, several years ago when for example NoSQL was sort of in the vogue, like a lot of people were talking about it because people were not because people are looking at alternatives for not dealing with like a structured data you would with the relational database, but like things like images and documents and so forth. So I think that's why it became very popular, and then there's also a lot of overlap between like database types. So I mean, I think earlier you alluded to vector database, which a lot of us are talking about nowadays because of AI.
Mhm.
I think, for example, a lot of NoSQL products, whether open source or not, are or even new SQL databases are adding like a vector search features, for example, right? So it's not just like I said with my comment on use cases, it's like the line's not necessarily like a black and white. So there's some blurring and then adding up like a non-traditional features, if you will, to different database types as well. But
Yeah. And
yeah,
even to add on
yeah,
that
hmm
further, it's like it, what I've actually seen as a very common trend with
hmm
companies that not even the ones that I work with, just friends and stuff that I know at other companies, is that um, they love toys. I mean, that's the nature of engineers. We love new tech and toys and whatnot. So
hmm
you have all these. You're right. It is a gray line, but I actually
hmm
think that um, a lot of times I think engineers maybe even think about it too much as like a a divided line. You have to use this database for that use case.
hmm
And databases that are built for everything are good at nothing, right? And so we need to use that
right,
dedicated tools. And what I often notice is companies will end up with massive database sprawl, where they
right,
have 10, 15 different databases all independently, all that have different, even like different query languages, right? And all need to be
hmm
independently optimized, independently upgraded, independently monitored, and particularly if you're a growing company, or even if you're a large company, this adds like massive amounts of overhead, right? And so I think
Mhm.
actually in situations like that, you really want to be looking to consolidate actually as much as possible, right? And even
Mhm.
looking to compromise on certain things. It's like, I kind of was bringing up like that TTL feature, which is something that kind of came up
Mhm.
recently in my work. Um, but if you can compromise on these like micro features, you can adapt your application to let's say a database that can handle multiple different workloads. Like
Mhm.
for example, SurrealDB is kind of a popular database like that. It's a multi-model like open source database that can kind of adapt or sorry um, accommodate a wide variety of workloads.
Mhm.
And TiDB is also like that to a large extent as well. It's like
Mhm.
TiDB has vector, it has OLAP, it has
Mhm.
transactional, right? And um, you know, if you can compromise on certain things, and I think with distributed databases, really the main compromise that you're making is going to be around um, internal customized database functionality,
Mhm.
like stored procedures. There are distributed databases that do stored procedures, but it's
Mhm.
not very good. And then latency. Those are like the
Mhm.
real two big compromises that will exist in that new SQL space. But if you can, it's actually will save you to consolidate. It will save you like a lot of headache. And there's
Mhm.
also different those are kind of just two examples. There's other open source databases that can kind of also provide that consolidation edge.
Right, right. Yeah, and I think the other challenge that we see, and obviously you see this more often than I do, uh, as businesses grow, nobody just uses one single database within the company. I mean, life would be so much easier if that were the
Yeah.
case for a lot of people, but that never ever happens, right? So
Mhm.
I mean, you see, it's not surprising if you talk to users or customers to see vendors using several different databases and even other data tools like data warehouses, for example. So I think that brings a lot of different challenges, but I mean that's I guess what you get paid for, Matthew. But
Yeah. I've even seen crazy things like I've
yeah,
seen companies have both MySQL and Postgres and have like fleets of them.
yeah, yeah.
Like, and it was just because they were managed by the application teams before the company grew a lot larger. And so one
Hmm.
team chose MySQL, another team choose Postgres. You could easily consolidate them onto like, one or the other, but
Hmm.
that was just kind of how the cookie crumbled. And now the data set is so large where it's just, it's too much of a pain. And so that's just kind of how it works. And so, yeah, it's kind of crazy.
Yeah, yeah. I mean, that's, I'm sure, like, when you're talking to the prospects, I'm sure you get a question about, hey, does TiDB work well with this XYZ data tool or data warehouse or et cetera, right? So, I think, I mean, not just us, but a lot of different communities spend a lot of time on like integration with other tools. But I think that's unfortunately the reality, right? I mean,
Mhm.
some of the examples I've seen, like especially if companies gone through acquisitions, right? Then two companies that or multiple companies that come together had different histories and different database tools that they use, and then that's how sometimes things like that happen. I think.
Yeah, and even on the integrations front of things,
Mm-hmm.
to make your life a little bit or easier, is you want to try and make your database choices around like the ecosystem around it, right?
Mm-hmm.
And because if you're choosing some database with some, like that has a language that's only exclusive to that individual database, you're building your application around it. That doesn't really give you a lot of options because what if you do end up in a merger? What if something
Mm-hmm.
has to change and then all these tools don't work with it? So that's why I think like actually MySQL compatibility and like Postgres compatibility are really, really helpful, right? Is because MySQL will allow you to go to a distributed database like TiDB, which is also compatible with all of the tools and all of the ecosystem that exists in MySQL, right? And
Mm-hmm.
that's true also with Postgres compatible distributed databases.
Right.
And if you see, specific tools and specific drivers and specific integrations that your app that let's say they're exclusive to MySQL or exclusive to Postgres, it's something that you should really be factoring in to your long-term decision, and even like the breadth of that ecosystem. And I think MySQL, just because it's been around longer, has a bit of an edge on that.
Hmm.
But I think also a lot of the newer Postgres is kind of the hot thing, and so a lot of the newer
Yeah.
tooling I've noticed is kind of more on that Postgres side of things.
Hmm.
You know?
Yeah, no, I mean, I think you're right. Like at MySQL, I've been to a couple of events where they're basically celebrating their 30th anniversary, right? I mean,
Yeah.
it's got a long history of uh, developers who are very familiar with MySQL, and that it has, the one of the strengths is not just the history, but it's got a pretty robust ecosystem as a result, right? So, yeah, you're right. I think it just makes a lot of people's lives easier. Because I've seen and talked to users that have migrated from MySQL to TiDB, that familiarity definitely really helps and sort of eases the anxiety. Because I mean, every migration, I don't care what you say, like migration is always going to be tough. Right? There's going to be a challenge, but it definitely it makes your life easier. Having that compatibility with a big community like MySQL. So,
Yeah, but I will
yeah.
say that you want the challenge as much as possible to be not on the application side of things. You want it to be
Right.
on the actual migration side of things, and
Right.
the application stuff can just spiral, right? Where it's just like,
Right.
oh, hey, I have to make some simple changes, then I have to change this, and I've changed that, and the scope of changes that might need to be made in your application might be quite large.
Hmm.
Um, but there's always going to be complexity in a database migration, but if
Hmm.
you can keep it on that database migration side of things, that's going to make your life a lot easier just in terms of like, coordinating the failover, coordinating the load balancer, yeah,
Hmm.
keep it on that side
Right, right, right. No, that's a good tip. I mean, that kind of leads in very naturally to I think this would be one of my last questions is, obviously you talk to a lot of people that are evaluating different database solutions and are very, one of the things that they're attracted to is that TiDB is open source and they're looking at other open source related databases. I mean, what are some of the key strengths that you talk about? I mean, obviously you and I are very biased. I mean, full disclosure.
course.
But what are some of the key, yeah, things about TiDB for open source like fans that you typically talk about?
I would say, well, I guess there's several variables to that.
Mm-hmm.
I think quite possibly one of the most valuable things about TiDB is its ability to be very friendly to multi-tenant workloads, to
Mm-hmm.
be able to run separate workloads all within the same system without interference. Like TiDB will allow you to run your both your tier 0 and your tier 5 like background jobs all in the
Mm-hmm.
same system without without a noisy neighbor issue. And we kind of do this
Mm-hmm.
through resource controls. We can kind of set resource quotas on individual workloads. So it's like if you want this workload to be super high priority and have an unlimited quota, you can do that. If you want this other low priority workload to only take this percentage up of the cluster, so features like that make it really useful in consolidating large scale systems and even bringing
Mm-hmm.
in multiple different multiple different types of workloads into the system. So like one thing that actually makes TiDB unique is its ability to handle analytical use cases. No other distributed database does that. So if
Mm-hmm.
you can consolidate both your MySQL clusters and your ClickHouse like all onto a single system, that just makes everyone's lives easier, and it's also cheaper because you're reducing the replication of data, right? So if you have to
Mm-hmm.
host the exact same data set in multiple different databases, like you're gonna be paying up the butt
Mm-hmm.
for that. Yeah, and so I would say that's kind of really one of its biggest strong suits, and then also scale. Like
Mm-hmm.
if you're apps you're like one of those super large companies, or you're a smaller company, and you have just a massive amount of volume or a massive amount of throughput. TiDB is going right now, I mean, depending on whoever listening to this podcast, listen to this podcast,
Mhm.
it's the most scalable of the distributed systems in terms of like its ability to handle large scale workloads. It'll handle more data volume. It'll handle more transactional throughput. It'll handle more table counts, everything. That's kind of really what the developers have been focusing on is really just making it bigger and bigger and bigger and bigger. And who knows that might end if someone listens to this in like 4 years, maybe it'll change. But like kind of right
Yeah.
now, I'd say that that's one of its big edges.
Yeah. Yeah. No, that's cool. And then, I mean, as a community manager, I also want to give a plug to our community members, because we're 10-year-old open source project. And if you go to our GitHub repo, if you look at a lot of like issues or PRs that are opened by non-employees, it's the numbers like pretty impressive. I mean, I wrote a blog post with our last stable release, sort of highlighting different external contributions, and that tradition lives on. So I think for a lot of open source aficionados, that's a key thing. And then I'm very proud of it. And as you know, although I'm like I said, I'm pretty biased, but I think we have a pretty healthy community engagement. So I think that sort of contributes to a lot of what you talked about is our important features would not be possible without our community feedback. So
No, definitely not.
yeah,
And actually, even
yeah.
to add to that,
Mhm.
so unfortunately for me, who I'm
Mhm.
I'm on the sales side of things. I'm a sales
Yeah.
engineer. We actually don't gate, really any features behind. It's like normally companies are like, oh, here's
Yeah.
the migration tool. Then, oh, that's gated. You have to pay for that or whatever. So no, we
Right.
we
Right.
open source everything, which is very unusual
Right. Right.
for most open
Yeah.
source companies. Yeah.
Yeah. Yeah. No, I mean, you're absolutely right. If you go to our documentations page, go to the tool section, you'll be pretty impressed with the amount, like the tools that we have for like the migration, et cetera, et cetera. So yeah, that's an excellent point. So cool. Well, Matthew, it's always a pleasure. Just talking to you casually in the office hallways or at conferences, but it's great to have you back on the podcast, and hopefully we'll have you back for other conversations in the future.
Yeah. Fantastic.
All right.
Thanks for having me on.
Cool. All right. Thanks. Yeah. So that sort of wraps it up. And yeah, we'll sort of skip the traditional, like, tell us about where you live. Like you had such a home run for Austin, but maybe we'll think of something else when you come back next time. So,
Yeah. Sounds good.
yeah. All right. Cheers.
Cheers.